Okay, hello everybody. Good evening, all of you guys. Please give me a thumbs up if you are able to hear me out. I hope that I am audible to you. Still, I'll check it. Okay, hello everybody. Good evening, all of you guys. Please give me a thumbs up if you are able to hear me out. Yeah. So, I am audible to you very clearly. But yeah, still, if you have any problem, please let me know. Yeah. So, once again, welcome to our lecture number 5. As you know that we are studying the classical thermodynamics. We have discussed the, you can say, 4 lectures in which we have discussed some basic part of the classical thermodynamics, right? And you can say the weightage of the classical thermodynamics from the GATE point of view. After that, we discussed the what is a system, what is a surrounding, what is the universe, right? And in the system, we discussed the open system, closed system, isolated system. Okay, is it clear to you guys, right? And after that, we have discussed the properties. After that, we have discussed the properties, right? And in which we discuss the intensive property and the extensive property. Okay, I hope that till this topic there is no doubt at all. But still, if you have any doubt, you can ask, guys. So please give me a thumbs up if you are watching me live. After that, we will start our lecture, guys. So today, basically, also we have discussed the state equation of the state, and in the equation of state we discussed what is a PV is equal to nRT, right? And what is this equation and what is the value of PV and nRT? We have discussed it. What is the process, right? So all these things we have discussed already. So today we will discuss the very important point, that is the point function, or you can say path function. Okay, so guys, let me know that I am audible to you, and जो भी क्लास में लाइव है एक बार thumbs up कीजिए, and also confirm that my voice is clear to you. After that, we will start our lecture. So as we discussed in the last class about the state, so in the state we have discussed that state is nothing but it is, you can say, a momentary condition of a system. What is the condition? So basically we define the state of the system by defining the pressure, temperature, volume, or you can say, or any thermodynamic property, right? But most of the system we define in terms of pressure, temperature and volume. Okay, so as far as our concern, or you can say, as if we talk about the GATE syllabus, then we talk about the, or you can say, we define the system by the P, V and T. So most of the time we talked about the pressure, temperature and volume, guys. Okay, so if we have to define any state of the system, then we define its pressure, temperature and volume at that moment, right? Is it clear to you? So it means that we have the 3 properties which is important, P, V and T. So what is the equation of state? Very simple. If mathematically we want to connect these 3 properties, then that equation, that mathematical equation is called equation of the state, right? Okay. So in the last class we have discussed the equation of state for the ideal gas. So as I already told you guys that there may be a number of equation of states, like van der Waals equation of state, Radlich, right? There are many types of the equation of state. Okay, so the equation of state for the ideal gas is PV is equal to nRT. PV is equal to nRT, or you can say PV is equal to mRT. Is it clear to you? So these two equations are equation of state, you can say, which relating these properties PV and T. So this is a proper, you can say this is the equation of state where this N is the number of moles and PV and T you know, and R is the universal gas constant, right? This is basically equation in terms of the molar mass. It is in the terms of number of moles. It is the in terms of M, right? Here it is my specific gas constant R. Is it clear to you? So these two equation of state in different terms. This is my equation of the state. Okay, what can be the value of P and V and T? I already told you. So as we discussed guys, that any condition is defining the state of a system, like it is the P1, V1, T. So at this state, my system has this value of these properties. At this stage, these are the values. At this stage, these are the values. At this stage, these are the values. So if we want to define a system, then we have to define PV and T. So if we have the value of PV, then also we can define the system. If we have the value of PT or we have the VT, then third component, third parameter can be easily solved with the help of the equation of state. Okay, right? So each point represents the unique state of the system. Okay, so if we move from one state to another state, that is called the process, guys. This is called the thermodynamic process. So what is the meaning of thermodynamic process? If we move from one state to another state, or it means you can say in the thermodynamic process, the state of the system is changing, guys. Is it clear to you or not? The state of the system is changing, right? So that is basically my thermodynamic process. So all these unique curve, all these curve is basically represents the what? It represents the process. It represents the process, guys. Right? Is it clear to you? Is it clear to you? Okay. So all this matter we have already discussed. Okay. All this matter we have discussed previously. So today we will discuss the point function. So please pay attention here that these small things are very important when we study the further. When we study the zeroth law, first law, second law, entropy and all those things, right? So point function. So as its name suggested, that point function is basically a property whose value depends only on the current state of the system. Is it clear to you? Or you can say it only depends on the initial and final state, guys. So it is basically not depend upon the path taken. What is the path actually? What is the path of the process? That is not important for the point function. I hope that I am clear to you. What I'm saying guys, that there are some properties which are only depend on the initial state and the final state. They basically do not care about the path taken by the process, right? So what are those properties like temperature, pressure, volume, internal energy, enthalpy, entropy? So these are some examples of the point functions, right? Let's suppose I'm giving you an example of the internal energy, right? So do not worry about it. About what? About the internal energy, because we will define the internal energy thoroughly when we will discuss the first law. Okay. So for till now, just understood like internal energy is a property, which is my point function. So let's suppose at this point, let's suppose this is my initial point, and let's suppose this is my final point, guys. There can be a number of ways by which my process can be undergo, right? My process can be complete. Whether it may follow this path, it can also follow this path, it can also follow this path. So there are three paths, guys. There are three paths, 1, 2 and 3, right? Is it clear to you? But mark my word, the initial and the final points, or you can say the initial and final state of all these three processes are same. So let's suppose at this path, my internal energy of the system is U1. For the path 2, my internal energy of the system is U2. And for the third path, guys, it is my U3. So my question is that U1 is equal to U2 is equal to U3. This is the correct expression. Or I can say U1 is not equal to U2 is not equal to U3. What will be my correct expression? What will be my correct equation? Right? So as we know that internal energy is a point function, it is only depend upon the initial and final state. So if you look for the process 1, process 2, process 3, all these processes have the same initial and final point. So what is the meaning? Meaning is that the internal energy of all these processes are same. U1 is equal to U2 is equal to U3. Why? Because the initial and final state are the same for all these processes. So basically in the point function, the property which is a point function, they are not depend upon the path. It is independent of the path, guys. It is independent on the path. Is it clear to you? Okay. So I hope that this point is clear to you. I hope that this point is clear to you, guys. Okay, another example is also noted here, that let's suppose I'm saying that a gas goes from 300 Kelvin to the 500 Kelvin. Means the initial temperature is 300 and the next temperature, you can say the final temperature is my 500 Kelvin. So what is the change in the temperature? 200 Kelvin is the temperature change. So it doesn't matter, guys, whether the heating was fast, whether the heating was slow or reversible, irreversible, means we do not take care about the process, right? So point function does not bother about the path. So this is what I'm saying, guys. Okay, so this is my important point, so just write this point. Now, so point function is basically, see, if any property which is only depend upon the initial and final state, then that is basically, its differential is exact. It is basically undergo the perfect differential. Means you can basically calculate the change. You can directly calculate the change. Like you can calculate the dV, you can calculate the dt, you can calculate the dp. So through the perfect differential, basically you can calculate the change in the property. Right? Is it clear to you? So that's why it is my, I can write dV, I can write dt, I can write dp. Okay, so this is also a very important point for us. Okay, right? Done? Now, so one which is depend upon the initial and final, there are some properties, or you can say which is basically the path functions. So please put the heading path function. Please put the heading path function. Right? Now, what is the meaning of path function? What is the meaning of path function? So as its name suggested, guys, path function is a quantity whose value depends on the path followed between two states. So it is depend upon the path. Point function depend upon the points, or you can say initial and final state. Path function is depend upon only the path followed. Is it clear to you? Is it clear to you? Different process between same state can have different values, guys. Right? So what is the meaning? I'm saying that this is my initial state and this is my final state. Okay, is it clear to you? Is it clear to you? Or let's understand this. I think that you will understand with the help of work done. Let's suppose, guys, this is my initial point. This is my initial state and this is my final state. And I want to reach from initial to final. So there may be a number of ways. So let's suppose I'm following this path from this to this point and this point to this point, or maybe this point to this point, or maybe from this to this. Is it clear to you? So tell me one thing, what you will think, the work done in all these three processes are same. This is process 1, this is the process 2, and this is the process 3. So think about the work, right? So work is nothing but it is the force into displacement. Let's suppose it is my force into displacement, the simple formula for the work done. So what you will think about it, guys, that what the W1 is equal to W2 is equal to W3. It is possible. It is possible, because if we see the initial and final state of all these, you can say the paths are same, right? Is it clear to you? So yeah, you are right, guys. So whatever you think that is the correct. So the W1 is not equal to W2, is not equal to W3. Why? Because they are path functions. It is depend upon the path. Their value can be different if they follow the different path. Is it clear to you? Let's understand this in a very easy language, that my work done is force into displacement, right? It is clear to you? चलो नहीं, इसको छोड़ो, ऐसे मत समझो, छोड़ो, right? And if you will say about the heat, then also it is Q1 is not equal to Q2 is not equal to Q3. So in the path functions, the quantities depend upon the path, guys. Okay, so the path functions are not exact differential. Means you can not write DEQ, you can not write DEW. No, this is the incorrect notation for this. You can put D only for the exact differential, or you can say the perfect differential, right? And all the point properties, or you can say all the point functions, are the exact differential. That's why basically you can write dB, dt, dt, du, dh, ds. But you cannot write dw and dq. Why? Because they are not exact. Right? Is it clear to you? So how we write that? Delta. If you want to represent the change in the heat or a change in the work done, then guys, instead of dq and dw, you will write this. You will write it. del Q, del W. Okay, right? So I hope that this point is clear to you. So we have point function, path function. First difference is it is depends only on the state. Means it is depend only the initial and the final state. Path function depend on the process path. Second point is it is exact differential, and path function is in exact differential. Right? Property of the system like T hai, P, U, like that. And it is basically not the property like it is my you can say your heat and it is your work done, like that. So you can say that all the properties are the point functions, right? You can say so that all the properties are the point function. So I can make a statement here, guys. You also can note that all the properties are point function. Okay, so these are the point function and the path function. I hope that you got my point. So whenever you watch this lecture, please, while watching it, please let me know that you are watching it, and if you have any problem you can ask. Okay, you can basically leave a message on the Telegram. Okay, let me ask you a question, and give me the answer of this question through the Telegram channel. Whenever you watch it, just please give me the answer. Let's suppose we have a state of the system, like we have some specific P, V and T value, right? We have some specific state of the system. I'm saying one properties only out of the three, one property is basically changed. One property is changed. Tell me that we can say this it is a process or not. I hope that you got my question. What I'm saying, you have a specific state of the system in which we define the P, V and T of the system, and any of the property is changed. Only one property is changed. This is the process or not, right? So you can tell me through the message. Just drop your answer in the Telegram group. Okay, let's move, guys. Now, next topic, please write down the thermodynamic equilibrium. Please note down the thermodynamic equilibrium. Okay. So what is the meaning of thermodynamic equilibrium? So thermodynamic equilibrium is an umbrella term. What is the meaning of umbrella term? There should be, you can say there are three types of the equilibrium. There are basically exist. If those three equilibrium exist for a particular system, then we can say that this system is in the thermodynamic equilibrium. Okay, what are those equilibrium, guys? So the system must be in mechanical equilibrium. The system must be in mechanical equilibrium. What is the meaning of mechanical equilibrium? Mechanical equilibrium means there should not be unbalanced forces. There should not be unbalanced forces, guys. Right? Is it clear to you? All the forces should be balanced. Like, see, this is the system. Let's suppose this is any gas cylinder piston assembly. So this is my gas, guys. This is my gas filled in this cylinder. This is my cylinder and this is my piston. At this piston, the upward forces and the downward forces are same. If these forces are same, upward forces and downward forces, if these forces are same, then we can say balanced force. Is it clear to you? So it means that there is no tendency of this piston for moving in any direction, up or down. In that case, we can say that system is in the mechanical equilibrium. Right? I hope that you understood my point. Second will be the thermal equilibrium. Thermal equilibrium. So as its name suggested, thermal equilibrium means that the temperature of the system is not going to change, guys. Is it clear to you? That what is the thermal meaning? Thermal meaning means the temperature of the gas, piston and wall of the cylinder is same. Right? It is clear to you. So temperature is basically equal. Temperature is basically equal. Right? So I can write here that the temperature of gas, piston and wall of cylinder must be same. Must be same. Right? So that condition is called thermal equilibrium. That is called thermal equilibrium. I hope that it is clear to you. Yes or no? I hope that this is clear to you. Okay. Now, third equilibrium will be chemical equilibrium. Third equilibrium will be the chemical equilibrium. What is the meaning of chemical equilibrium? Very simple. Let's suppose if my working gas is ammonia, let's suppose. If it remains the ammonia, means there is no reaction at all. There is no reaction at all in this system, in this gas system. If there is no chemical reaction is going on, then we can say that this is my chemical equilibrium. So in the thermodynamic equilibrium, we define the three equilibrium: mechanical, thermal and the chemical equilibrium. So if all these three equilibrium exist simultaneously, right, they should be existed simultaneously. That state of the system is called thermodynamic equilibrium. I hope that this is clear to you guys, right? It is clear to you or not? So just I'll write it for you that if, please note down this on your notebook, if all these equilibrium exist simultaneously, the equilibrium is called thermodynamic equilibrium. So this is the definition for the thermodynamic equilibrium, right? I hope that this is clear to you. I hope that this is clear to you. Okay. Yes. So this is my thermodynamic equilibrium. So you can say if all these three equilibrium existed for a system, then it is my thermodynamic equilibrium, right? Yeah, Muhammad, are you just came just for now, or you joined our class at the 7 o'clock? Yeah, Muhammad, please let me know that you are here for at this from 7 p.m. or you are just be here at 7:30. Okay, but you should tell me that, sir, yeah, I'm here, right? You should tell me that I'm here, you are audible, right? Yes or no? है ना, आपको बताना चाहिए. If I'm not able to figure out that you are not here or not, then how can I be sure that you understood all the things or not, right? How I interact with you if I'm not basically aware about it that you are in the class or not. So whenever you join the class, it is for everybody. Whenever you join the class, please let me know that we are watching the lecture, so that at least I can interact with you. ठीक है? Interaction with student is not the benefit of the teacher, first of all, right? I make you very clear about it. It is only about you, right? Because from by the, you can say, interaction helps us to unfold some deeper concept. Okay, and if it is the class at the 7 p.m., please try to join the class at the 7 p.m. because in the first class I told you that initial 4 to 5 lectures are very important for us, because in these lectures teachers basically trying to build up the foundation. If my foundation is strong, then there will be no issue. In the middle of the subject, if you miss any lecture, then there is no issue, you'll cope up. But if initial things are missing, then it is not easy to cope up all the concept very clearly. Okay, please ये बात थोड़ा सा ध्यान रखें. It is for everybody. Yeah, so yeah, your doubt is, sir, can you explain the chemical equilibrium once again? Yeah, I can explain, Muhammad. See, what is the meaning of chemical equilibrium? So chemical equilibrium, let's suppose any chemical reaction is going on. Let's suppose it is my A plus B and it is gives me C. This is, let's suppose, my equation, right? It is my, let's suppose, any chemical reaction is there. So whatever the product, whatever the reactant is converted into the product, or whatever the product, because it is the reversible reaction, whatever the product is converted into the reactant, it is basically, this process is basically completed now. No further reactant can be converted into the product. No further product can be converted into the reactant. Means that the driving force for this chemical reaction is equal to 0. Right? I hope that you know that for any chemical reaction is to be happening, there should be a driving force for that. So that driving force is basically 0, or you can say the rate of the forward reaction this is my forward reaction, is equal to the rate of the backward reaction. Whatever A plus B amount is converted into the C, the same amount is converted into the A plus B. Is it clear to you? So if you see overall picture, then there will be no any production. There will be no any new production. Right? It is clear to you? Or you can say the driving force will be zero. That state is called the chemical equilibrium. That state is called the chemical equilibrium. Right? I hope that, Muhammad, now this is clear to you. Boliye. This is clear to you. I hope that this is clear to you now. Okay. Can we move forward? Can we move forward now? Okay. Now guys, from this topic, please pay attention here. Now you can say we have discussed so much basics of this subject, some basic terminologies, the things we already covered it. Now from this topic, now from this slide onwards, please pay attention here. Now there is a requirement of your attention. Okay, so let's understand this. So first of all, please put the heading work done by a gas. Work done by a gas. So we studied the two, you can say, things in the path function. One is the work and another is the heat. And at the first lecture, in the first lecture, we have discussed that basically we will study in the thermodynamics interaction of the Q and W, or you can say the interaction between the energies. Right? So from this lecture onwards, we basically started from this topic. Work done by a gas. So what is the meaning of work done by a gas? So we will try to first calculate the work done by a gas. So guys, see, this is my cylinder gas piston system, right? So this is my cylinder and this is my piston, and as you can see here that this is my gas basically, which is confined in this space, right? A is the area of this piston. A is the area of this piston and P is the pressure here. P is the pressure here. I hope that this is clear to you. And I basically try to calculate the work done by this gas. I basically try to calculate the work done by the gas. Okay. So guys, see, let's suppose at this section, what is the force applied by the gas on the piston? So first of all, I hope that you guys are aware about it, but if you are not aware about it, please note it down. What is the meaning of, guys, pressure? What is the formula for the pressure? What is the pressure? Pressure is nothing but it is the force per unit area. It is a force per unit area, right? It is clear to you. So if I am interested to calculate the force, that force is nothing but it is the pressure multiplied by the area, right? So this is my piston. At this piston, this gas is basically applying a force, amount PA. Amount is my PA. Is it clear to you? Right? So by this force, this gas expands. Let's suppose this piston is moving at this position. This is my initial position, and you can say this is my final position, right? How much I move this piston, or how much this force moved this piston, you can say, let's suppose it is my delta x, or you can say it is my dx, whatever you want. So this is my, guys, initial position and this is my final position. Is it clear to you? Is it clear to you? So what is the force? Force is the pressure into the area, PA. And what is the displacement of this piston? Delta x is the displacement of this piston, right? It is clear to you. What I'm trying to calculate? Work done. What I'm trying to calculate? Work done. So what is the formula for the work done? Work done is nothing but it is a force multiplied by displacement. right? What is the force? Force is my pressure into area multiplied by displacement. Displacement is my delta x. It is clear to you? So what is the work done? Work done is my P multiplied by area into the delta x. What is it? It is my change in volume. Yes or no? Area into length. Area into length, guys. Yes or no? And if it is delta x, then it is my delta V. So what is the work done? Work done is equal to W is equal to P delta V. Work done is equal to P delta V. Right? Is it clear to you? Or in other words, or in other you can say form, what I can write it. See, let's suppose that this initial to final position. Let's suppose this is a very small change. This is a very small change. I hope that guys you are aware about it, that we denote delta means the big change and D is for the small change. Let's suppose that this change is very small. So what is my work done? There will be a very small work done. Yes or no? It is clear to you? What is the work done? Small work done del Q, which is equal to force, multiplied by the displacement. What is the force? Force is my pressure into the area. And what is the displacement? Displacement is my dx. Right? So what is del W? Del W is equal to P and A dx is my dV. So del W is equal to my PdV, guys. What is the formula? Del W is equal to my PdV, right? And if I want to calculate the whole work done, if my change is very big, then I can write it by integrating both sides. By integrating both sides, I can write my W is equal to integration P dV from volume V1 to V2. From volume V1 to V2. This is the formula for the work done by the gas. Please note it down and tell me if you have any hurdle in this. Please tell me. This is very important and this is a very interesting thing. Okay. Yes, Mohammed. Is it clear to you or not? Yes, tell me. It is clear to you or not? Any query at your side? Okay, done. Okay, so W is equal to, in big change we can say P delta V, right? P delta V, right? And for the small change it is my W is equal to integration P dV from V1 to V2. After W is equal to P del V, कोई नहीं, there is no problem at all. See what I'm saying? नहीं, इसमें there is no problem in that. See, it is nothing. See, let's suppose this is my piston, right? This is my piston. Area of the piston is A. Okay, and let's suppose pressure is my P, and what is the force? Force is the pressure into area. So this piston is having a force. If you see this piston only, let's suppose this is my piston. This is a piston, right? And pressure, force P into A is acting on this piston. By this P into A, my piston is moving by the amount. This piston is moving by the amount dx. What is the amount? Dx. Dx means when we use d, when the change is small, when we use delta, when change the big. That's it. What is the work done? Work done is mine. So in this small displacement, there is a small work done. There is a small work done. That's why I write del W. Del W means a very small work done. Right? Is equal to force. Force is a pressure into area. Multiply by displacement. What is the displacement? Dx is the displacement. Del W is equal to P multiply by A dx. What is the A is the area and dx is the change in the length, you can say. So what is it? It is my change in the volume. Yes or no? A into dx is my change in the volume. If I want to calculate the whole work done, means if my let's suppose this is my, let's suppose that this is my cylinder and this is a piston initially, and I calculate here from here to here only, it is my displacement is dx. If I'm interested to calculate the work done if my piston is here, if this piston is here, so in that case this is my initial and what is the final point? This is my final point. So what we have to do, just integrate all these chote work done, right? This work done, this work done, this work done, right? That's why use the integration. So what we will do, just integrate this, integrate this, integrate this. So after integration, what is it? It is my W, means the total work done is equal to P into dV and its integration. So integrate from V1 to V2. What is the V1? Initial volume. What is the V2? Final volume. It is clear to you? ये क्या आ गया? What is this? This is a total work done. If you will write it, then this is the same thing, guys. What? P is equal to this P. W is equal to P. What is the dV? What is the integration of dV? It is V. V only. Upper limit V2, lower limit P1. What is it? P into V2 minus V1. What is my V2 minus V1? It is nothing but it is the delta V ना. So क्या आ गया? वापस से what is it? It is equal to W is equal to P into delta V. It is the same thing. Yes or no? Right? So I just write it before calculating it. I just write it before calculating. If you calculate this term for the volume change, then you can write this thing. So if you know the initial and the final volume, you can directly use this, you can say the formula, P delta V. Yes, Mohammed? Am I clear with this? If you know the initial and final volume, then you can calculate easily the change in the volume, then just calculate the work done. W is equal to P into delta V. Is it clear to you or not? It is clear to you or not? Am I clear with this or not? So this is important, guys. No? This is important. If you know this, you can calculate this also, you can calculate this also, or you can calculate the work done if it is there in any variation in the P and V. Right? Okay. Okay. Right, so I hope that you noted down. So see, just now we will try to plot this graph, or also we can plot this graph mathematically also, but let's understand this graph also. See what I'm saying. So let's suppose this is my any cylinder piston arrangement, and this is the gas which is filled into it, and I want to plot the P and V graph. I want to plot the P and V graph for this. Yes, okay, I want to plot P and V graph for this. So let's suppose this is my initial volume. This is my initial volume, right? Let's suppose my initial volume of the gas, guys. Okay, this is the volume of the gas. I hope that you are aware about it. So my initial volume is Vi. Let's suppose that my initial volume is V1. Okay, now as I know that the gas is basically pushing this piston outside, so let's suppose this, by the force P into A, my piston is at this side. Now the new volume of the gas is V dash. Is it clear to you? So tell me, Muhammad, that this is my expansion case or contraction case. There is a two thing: expansion, this is my expansion, or it is contraction. Please tell me if you are aware about these two terms. This is my expansion or contraction. This is my expansion or contraction. No idea, Muhammad? See, expansion means very simple. What is the meaning of expansion? That something is basically going to expand. If something is going to expand, it means its volume increases. Its volume increases. Yes or no? If its volume is increases, then its pressure will be decreases. Pressure will be decreases. Let's suppose you are 10 people, which is in a room, right? And just you are in a room, and room is full of you can say 10 person. There is no, you can say that there is no so much space in that confined space. Now I'm saying that just reduce the size of the room. Same number of people now can adjust in that half volume room. Please just think about it. What is the case? What will be your condition? I think you will pushing the walls so much. Is it clear to you? Means that you are pushing the walls so much, means that you are exerting so much pressure, right? You are exerting so much pressure by if we reduce the volume. Is it clear to you? So there are two cases: expansion. Expansion means there is increment in volume but decrement in the pressure, and there is a contraction. Contraction means volume is decreasing and pressure is increasing, right? So from here to here, my volume is increasing. As you can see, this is my x-axis, and at this x-axis, this initial is my V1 and this is my V dash. And from this graph, this line, you can say that V dash is greater than V1. So if my volume is increasing, then my pressure will decrease. So here at the I point, this is my pressure, and at the V dash volume, see, the pressure will decrease. Now the pressure is this. Pressure is decreased now. Okay. Further, gas basically expands, volume will increase, pressure will decrease. Further, there is expansion, volume will increase and pressure will decrease, right? Further, the volume will increase and my pressure will decrease, and this is my, you can say, the final position of the piston. Is it clear to you? So this kind of graph, this kind of PV graph you will get from the equation. W is equal to integration P dV from V1. If it is initial or final, I can write it also V initial to the V final. V initial to the V final. Is it clear to you? Is it clear to you or not? It is clear to you or not? So this is the PV graph, and this is my you can say the mathematical you can say the explanation for this. Yes, Mohammed, this is clear to you or not? Tell me this is clear to you or not? Okay, but you got my point or not? You got my point or not? So this is my work done. This is my work done. Now, if we'll go back, or you can say if we will go back from this formula to this graph, then what we can say? Now basically we go from this graph to this formula. If we will say that let's go from this formula to this curve, then what we can say? See, I'm saying guys, see, expansion means, what is the meaning of expansion? Expansion means there is an increment in the volume. Volume will be increasing in the case of expansion. If volume will increase, then pressure automatically will decrease. Why? Because now whatever the amount is basically confined into that space, that have the extra, you can say, space to settle down. It is clear to you? It is clear to you? So in the expansion case, there is an increment in the volume and pressure will decrease. In the contraction, what is the meaning of contraction? In the contraction, volume will decrease. If volume will decrease, then same amount of the matter exert the higher pressure on the walls. Why? Because now space is, you can say, reduced. There are less space for the molecules to be settled down. So let's suppose this is my initial condition of the piston. Let's suppose this piston is my at this position. This is my initial. So this is my initial state. At this initial state, volume of the gas is V1. This gas exert the force on this piston, and it is basically this piston is basically expanded till this V dash. So from here to here, first this is the volume. Now what is the position of the piston? This. Now this is the volume. Volume will be increased. If my volume will be increased, let's suppose this is my volume. So V dash is obviously greater than the V1. So if this is the volume and this is greater than the V1, this my volume will be increased and the pressure will decrease. At the initial stage, this is the pressure. At this volume, this is the pressure. So this is how, if my piston is at this position, so volume is, you can say now, full volume of the cylinder. So volume will increase. If my volume will increase, my pressure will decrease. So this is my final position, right? So the pressure at the final position is this, which is less as compared to the initial. Yes or no? So this kind of curve we can get from the, you can say, this experiment. So if we plot this experiment in the PV graph, then this kind of curve we can get. This kind of graph we can get. Is it clear to you? Now, W is equal to integration PdV. What is the physical significance of the integration? So basically integration, if you are aware about it, then it's very good. If you are not aware about it, then just please put this information in your notebook, that integration means area under the curve. Integration means area under the curve. right? So this is the integration PdV. What is the meaning? Meaning is that in the graph P and V, this integration shows the area under the curve. Area under the graph between P and V now, so area under the PV curve. So this is basically showing area under the curve. It means, can we say that area under the PV curve gives me the work done by the gas? Please tell me. Can we say this, yes or no? Through this integration formula, can we say that area under the curve gives me the work done by the gas? Work done by the gas. Yes or no? Please let me know that this is clear to you or not. Mohammed, this is clear to you or not? So integration means area under the curve, right? So it is the integration of PdV, it means area under the PV curve. So this integration term is equal to W, and also this integration terms is basically equal to area under the PV curve. So it means if we have the PV graph, guys, if we have the PV graph and if we will calculate the area of that curve, then we can get the work done by the gas. Yes or no? Right? Is it clear to you? So let's pay attention here. Pay attention here. This is my curve from initial to final, right? So the initially my piston is here, and my finally my piston is here. Is it clear to you? So this gas is basically doing some work. That's why this piston is moving from this to this. For this movement of the piston, gas has to be some gas basically done some work. What is that work? What is that work? That work is basically area under this curve. Area under this curve. This is basically the work done by the gas. This is basically the work done by the gas. I hope that there is no issue. Yes, I hope that there is no issue. Yes, can we move forward now? Okay. So my W is equal to PdV from V initial to the V final, right? Okay, so as we already discussed about it, what is the work done, guys? Work done is my path function. Work done is my path function. So it is basically depend upon the path, right? What path you basically follow, okay? If we will talk about the unit of work, then what will be the unit? So work done is equal to force into displacement. Force unit is my Newton, and this displacement unit is my meter. So this is my work done. Work is equal to Newton meter, and this Newton meter is called basically joule, right? And the symbol for the joule is J. So joule is the unit of work done. Joule is the unit of work done. Okay, done? Okay, great. Okay, please put the heading some important points. Some important points, and please pay attention here. These are the very important points about the work done. If we will go through all these important points, then you can solve any question related to the work done. I am giving you this assurance, guys. I am giving you this assurance. If you are go through these important points, then there will be no chance of, you can say, that you are not able to do any question related to the work done. What are those important points? Let's discuss. So please put the point number 1. Okay, so let's suppose in the point number 1 we are discussing the sign convention. Sign convention for work done. Sign convention is very, very important in the thermodynamics, right? So in the sign convention, let's suppose I'm saying that work is done by system. Work is done by the system, right? So let's suppose this is my cylinder, this is my piston, and this is my gas, right? This is my gas and this is my system. Actually, this is my system. This is what we are basically observing. So this gas is this basically gas is applying a force, and due to that force this piston is moving in the upward direction. Yes or no? If this piston is moving in upward direction, means that the system is basically, we are getting the work from this system. Yes or no? It is clear to you? If this piston is moving in the upward direction, it means that we are getting work done through this system. Yes or no? It is clear to you or not? So in that case, my work done is positive. My work done is positive. Work done is positive means that, see, if my work is done by the system, then for sure this volume will increase. This volume will increase. Yes or no? So if work is done by the system, then we can write 2 comments that work done is positive and my volume will be increased, right? Second, if work is done on the system, right? So what is the meaning of work done on the system? Let's suppose this again, this is my cylinder piston arrangement, and surrounding is basically applying some force on to this piston, and so that this piston goes in the downward direction. Yes or no? So basically surrounding is applying the, you can say, the force onto the piston actually. So this is the basically work done, which is we are doing the work done on the system. We are doing the work done on the system. Like I don't know that you have done this practice or not. जब हम छोटे बच्चे होते थे तो साइकिल में जब हमें हवा भरनी होती थी टायर्स के अंदर, so we basically doing we will have a pipe. एक पाइप होता था भरने के लिए, पंप होता था, that is pump actually, and we are pushing downward. We are basically pushing downward, है ना? उसको हम क्या करते हैं? Push करते हैं नीचे की तरफ, right? So in one stroke that it will suck the air, and in the downstroke it will basically injecting the air into the tire. Yes or no? So what is that basically scenario? We are if that air pump is my system, then we are doing the work on the system, right? So if we basically doing the work on the system, then volume will decrease, right? And work done in this case is positive. Sorry, work done in this case is negative. Work done in this case is negative, and volume will decrease. These sign conventions are very, very important. When we will go through the questions, then we should remember this sign convention. According to this sign convention, we have to put work done as a positive or negative. So it is very easy to remember. If we have to do some work, if we have to do some energy or if we have to do some spends on anything, that is negative for me. If we are getting something from others, then it is positive for me. So if we are getting work from the system, it is positive for me. That is work done is positive. And if I have to do work done on the system, it is negative for me because I have to spend my energy for this. So that is negative for me. So work done will be negative. So this is how you can remember this thing. Is it clear to you? C point, if volume will be constant. If volume is constant, it means work done is 0. Work done is 0. Yes or no? As we know that work done formula is P is equal to P delta V. Delta V means change in the volume. If their volume is constant, then delta V is equal to 0. In that case, my work done will be 0. My work done will be 0. Please note this. Yes, Mohammed, is it clear to you? I hope that this is clear to you. Okay, great. Second point. These are very important points, guys. You will not find these points in any book. If you want, you can try. Okay? If you want, you can try. I solved thousands of questions. Out of those thousands of questions, whatever I learned, I'm giving you that crisp thing that is basically required directly to hit any question. Okay, second number point, if let's suppose my pressure is constant, let's suppose if my pressure is constant, in that case, how to calculate the work done? So work done is equal to integration P dV. This is the formula. Please remember this formula. This is the important formula, right, to calculate the work done, and it is my from V1 to V2. So as you know that if pressure is constant, this pressure P can be taken out from the integration. Why? Because this P is constant value. So it is my P integration dV, and it is my V1 to V2. So what is the work done? Work done is equal to P into dV. Integration is V. By putting this limits, it is my V2 minus V1. So this is the work done if my pressure is constant. If my pressure is constant, right? It is clear to you? Or I can write it as P into delta V. P into delta V, right? Is it clear to you? Let's suppose, guys, that if the gas is ideal gas, if gas is ideal, then we can write PV is equal to nRT, and as we know that pressure is a constant, right? This is my condition now. Pressure is constant, right? Okay, and we know that my R is constant, means universal gas constant is constant, N is my constant number of moles, right? Then if my volume will change, then temperature will also change. So in the change term, I can write that P delta V is equal to nR delta T. I hope you understood this manipulation. PV is equal to nRT is the gas equation of the state, ideal gas equation of the state. Yes or no? I'm saying P is the constant. P is the constant. So if volume will change, then temperature will also change, right? So I can write P delta V is equal to nR delta T. So if I put this manipulation in the above equation, then work done by the gas can also, we can write it is my P delta V, or nR delta T. So it may be possible that they will ask you a question, calculate the work done by the gas. Calculate the work done by the gas if initial temperature is this and final temperature is this and pressure is constant. If they will ask that pressure is constant, initial temperature is this and final is this, then you will think about it. यार सर ने तो हमें बताया था that work done is equal to P delta V, but here there is no data of the volume. Then how can I solve the question? Then it may be possible that question is wrong, or it may be possible that sir gave us the wrong information. No, if you have the temperature data, then use this formula, guys. Work done is equal to nR delta T instead of the P delta V. So if you have the volume data, then use this formula. Work done is equal to P delta V, and if you have the temperature data, then use this formula. Work done is equal to nR delta T. Right? So I'll write it in this way so that there is no possibility of any mistake. Please. Yeah, Mohammed, it is clear to you or not? It is clear to you or not? Please tell me. Yes, Mohammed, am I clear with this or not? Please tell me that I am clear with this or not. Okay, now it may be possible that you think, sir, what is the new in this? Work done is equal to P delta V, we know this. Work done is equal to P delta V. Multiple times you told us. What is the, you can say, what is the new thing? Here you already explained this. Here you already explained this, right? What is the, you can say, new thing in this? Here you already saw this, you already discussed this, sir. Okay. Yes, I know that I already discussed this. Why I explained here. If my P is constant, let's suppose if my P is not constant, guys. Let's suppose if my P is not constant. So please put the point 3, P. If P is my function of the volume. If P is my function of the volume, if my P is the function of the volume, then you cannot write that formula directly. In that case, we have to use some, you can say, the mathematical manipulations. The formula will be, we will calculate some different formula for it. How? See, very simple. If my pressure is equal to function of volume, and it is given in the question that my pressure is equal to alpha V square. This is how my pressure is connected to the volume, guys. And here alpha is my constant, okay? Here alpha is my constant. This is my question. Now we have to calculate the work done by the gas. Now we have to calculate work done by the gas. If pressure is not constant, it is function of the volume. How to calculate? Very simple. Work done is equal to, formula is my P dV, and it is my V1 to V2, right? V1 to V2. Now understand, you cannot take out P outside the integration. In the previous slide, we take out this P from outside this integration. Why? Because P is constant. Now P is basically variable. It is basically going to change with respect to the volume. So we cannot take out P from the integration, right? Instead of it, we have to put P value in the integration, right? So what is the P value? What is the P value? Work done is equal to integration V1 to V2. P value is my alpha V square. This is P value alpha V square into dV. Alpha is my constant, you can take out from the integration, and it is my V square dV. What is the integration of V square? It is my V3 divided by 3. This is the integration of the V square dV, and it is my V2 to V1. This is my work done. So finally, what will be my work done? Finally, what will be my work done for this expression? So my work done is equal to alpha V2 cube minus V1 cube divided by 3. This is my work done, guys. This is my work done. Right? Is it clear to you? Let's suppose question is saying that, let's suppose my volume is changing from V0 to 2V0. Means initial volume V1 is equal to V0 and my final volume means V2 is equal to 2V0. So the problem is simple, just put here value. Work done is equal to alpha by 3 into V2. What is the V2? 2V0 and its cube. So it is my 8V0 cube minus V1 cube. What is V1? V0. So it's V0 cube. What is the value? Work done is equal to, it is my 7 alpha by 3 V0 cube. This is my answer, guys. This is my answer. Please note it down and tell me if you have any hurdle to solve this problem. If you have any problem, you can ask. Please tell me. So you have to check whether my P is constant or it is any or it is function of any other property, right? Eight V note beta. See, what is this formula? What is this work done? Alpha by 3 V2 cube. V2 cube, na? It's, see, you are aware about the integration, Muhammad? V2 square, okay, V square dV and its integration from V1 to V2. What is V1? It is the initial volume. Or what is the V2? It is my final volume. What is the integration of this? It is my V3 divided by 3. V square dV integration is V cube divided by cube. Yes or no? Just increment 1 by 1 in the power and it is divided by the same number divided by the same number. Yes or no? And just put the limits here, V2 and V1, right? Put here 1 by 1. Just you can take out 1 by 3 common from at the place of V, just V2. So it is my V2 cube minus the lower limit V1 cube. So V2 is my final volume. So what is the question saying? Question is saying that volume is changing from V0 to 2V0, means that it is my initial volume and it is my final volume, right? So it is my V1 and it is my V2. So what is the value of V2? V2 value is 2V0. So just put here V2 cube means 1 by 3 into V2. What is the value of V2? 2V0 and its cube minus V1. V1 is my V0 and its cube. So 2V0 cube is 8V0 cube. Okay, Muhammad? Clear with this? Clear with this? Clear with this, yes or no? Please tell me this is clear to you or not. This is clear to you? No, it's not about okay, Mohammed, you are clear with it or not. I am saying Your answer, I suppose your answer should be yes or no. Yeah, right. It's nothing like that. If you are not getting me, and I'll move forward, right? So it's not going to happen, guys. So first of all, tell me that you are okay with it. Just you grab that concept, you understood the thing or not. That is the main important thing, right? We'll take some, you can say, the more lecture, but we will not compromise with the study of the students, right? Okay. So this is my third point. Now what is the fourth point? Fourth point, let's suppose, okay, P is equal to, let's suppose it is my function of temperature. My third point will be if my pressure is function of volume. Let's suppose now my pressure is the function of temperature, and let's suppose it is P is equal to nothing, it is by alpha T square, and here same alpha is my any constant quantity. Okay, now in that case we have to calculate the work done by the gas if temperature is changing, if temperature is changing from T0 to 3T0, right? So what is the initial temperature? T0. What is the final temperature? 3T0, right? Again, what I'm saying, we have to, what is the formula for the work done? Work done formula is equal to integration P dV, and it is my from initial volume to final volume. Now sir, in that case what we will do, because if you put P as alpha T square, but here the differentiation, or you can say the integration, is in the volume, and here this term is T, temperature. How we solve this? Right? See, I don't know you are getting my point or not. Work done is equal to integration V initial to V final, right? So it's your choice. You can mark V1 to V2 or V initial to V final, right? It's your choice. Instead of P, put the value alpha T square into dV. Here there is no information about the temperature. That temperature is constant. So please do not assume by yourself that temperature is the constant quantity. Yes or no? See, the mistake can be like this. You put alpha T square outside the integration and just integrate dV. No, this is the wrong approach. Why? Because in the question, temperature is changing. It means temperature is not the constant quantity, guys. Temperature is changing. It means temperature is not a constant quantity. And dV is also there. It means that dV is also, volume is not constant here, right? So how to solve this question? So it is so obvious that if we have the T and V, this equation must be whether it is in the T or this equation must be in the V, right? So whole equation must be either in the T or in the V. Is clear to you? So how to calculate this? How to solve this? See, so P is equal to what? P is my alpha T square. It is given. And also PV, from the PV is equal to nRT, we can write that P is equal to nRT by V. PV is equal to nRT, right? This is we know, and as you know that we are basically no beta, double integration. No. Double integration is a different approach. We cannot do the double integration. If in the formula of the work done there is a single single integration, then how you can put the double integration, right? There is no any requirement of double integration in the classical thermodynamics, right? So forget about the double integration. If this is my formula, this is, you can say, the basics of anything. If this shows the single integration, then how we can put the double integration? No. We have a very simple approach. So P, from the PV is equal to nRT, I can write P is equal to nRT divided by V. And P is equal to alpha T square, this is also given to you. So P is equal to this and P is equal to this, then for sure we can write alpha T square is equal to nRT by V. Because pressure is equal to alpha T square, pressure is equal to nRT by V, it means that both quantities are same. Is it clear to you or not? So from 1T to 1T, it is gone, and if I calculate the value of the V, then V is equal to nR divided by alpha T. So V is equal to nR divided by alpha T. Is it clear to you? And here it is my dV. Here it is my dV. Yes or no? So what is the value of dV here? What is the value of dV here? See. So what is the value of dV here? So dV, just do one thing, just differentiate this V. Just differentiate this V. Okay, so it is my dV. I hope that you know the differentiation of U by V. So it is my dV is equal to, see, nR divided by alpha. This is my constant quantity. Yes or no? It is my constant quantity. What is the differentiation of 1 by T? 1 by is my y minus 1 by T square into dt. This is the dV value. This is my dV value. Right? Is it clear to you? What I do here? Nothing. V, just differentiate V as dV is equal to nR divided by alpha and 1 by T. So just I differentiate 1 by T. So what is the differentiation of 1 by T? It is my minus 1 by T square into dt. This is the differentiation of 1 by T. This is the differentiation of the 1 by T. Right? I hope that you are okay with this. Hanji, bolo. You are, I hope that you are okay with this. Okay? Bolo. Right? So this is my dV. Guys, now you have everything. You have everything. Now it's up to you that how you solve this question. This is now up to you how you solve this question. I'm giving you all the values. So please solve this question, calculate the value of the W and post it to the group. इसको group पे आपको भेजना है. This is your homework. This is the further, the solution of this question is your homework for the tomorrow. ठीक है? This is your homework. So I'll discuss it in the next class. Just solve this further. Just calculate the value of the work done. Right? So I hope that you enjoyed the class. You learned so much things. But still, if you have any doubt, if you stuck anywhere, just let me know, guys, through the Telegram channel. I will explain you everything there also, and whatever it's required, I'll be there for you in your preparation, right? But just stick with me, stick with the EiiDelhi team if you want to get a very good rank and if you want to join the PSU. Right? So yeah, so it's my request, just revise all the things very seriously. Just take all, you can say, each and every word of your contact very seriously, right? There is no space of, you can say, casualness, right? So casual nahi hona hai, granted nahi lena hai. Thank you so much. Bye bye and take care. Let's meet in the next class. Yeah, for the next class there will be a change in the timing, so I will tell you the timings, so follow that timing also in this week, right? After this week we will schedule your class in the evening slot, but yeah, in this week your class will be in the morning slot. So just prepare with it, just revise it, and let's meet in the tomorrow. Thank you so much. Bye bye and take care, and just solve this homework, okay, and post it to the Telegram channel. Bye bye and take care, guys.